This question is about finding the eigenvalues from given eigenvectors and use that to solve this system of differential equations. Now let's start with question A. What if you're given the eigenvector? Usually you're just given the matrix and you have to figure out these eigenvectors on your own, but this question is trying to save you time by giving you the eigenvectors. So how do you get that? Well, think about the definition of an eigenvector. Eigenvectors are where if you multiply the matrix to the vector, it acts as if it's just some multiple of the vector itself. So since A is this matrix, negative 41, negative 60, 24, 35, let's try to multiply 3, negative 2 and see what we can get. Well, you multiply vectors and a matrix, a column vector and a matrix by going across down. So you see that you get negative 41 times 3, which is negative 123, and then negative 2 times negative 60, which is positive 120. On the other hand, 3 times 24 is 72, and negative 2 times 35 is minus 70. So that gives you negative 3 and positive 2. So what happened between this and this? Well, you see that 3 became negative 3 and negative 2 became 2. So this is like negative 1 times 3, negative 2. And as you can see, indeed, this vector satisfies the eigenvector equation with lambda being equals to negative 1. In the same way, this time, let's multiply the matrix with the second eigenvector, which is 5 and negative 3. 5 times negative 41 is negative 205. Negative 3 times 6, negative 16 is plus 180. 5 times 24 is 120. 35 times 3 is 5, and then 105. Okay, so with the minus, and that gives me, let's see, that's negative 25, and this one is positive 15. And again, you want to think about 5 times what gives you negative 25. It's negative 5 times, right? So if you put negative 5 times negative 3, indeed it's 15. Negative 5 times 5 is negative 25. So you do see that this time the eigenvalue for this vector is negative 5. So these are the eigenvalues. Okay, once you know the eigenvalues, we are able to write down the equation, the solution for a differential equation. So from this, the general solution, because this is represented as matrices with this exact same matrix that we just found out, we just worked with, and we know that the eigenvalues are lambda equals to negative 1 with eigenvalues negative 3 and 2, actually positive 3 and negative 2, and we also had lambda equals to negative 5 with eigenvector 5 and negative 3. So these together tells us that xy should equal to the c1 times the first eigenvector with its eigenvalue plus c2 times the second eigenvector with its eigenvalue right here. And you also need to be able to read off the x and y separately in order to use the initial conditions. So x reads as x equals to 3c1 e to the negative t plus 5c2 e to the negative 5t. On the other hand, y is negative 2c1 e to the negative t minus 3c2 e to the negative 5t. Alright? And then that's where we use x of 0. X of 0, if you plug in 0 in these, you just get e to the 0th, which is 1, right? So you get 3c1 plus 5c2. And the initial condition says that it has to be negative 21. y of 0, according to the equation that we just found out, is negative 2c1 minus 3c2, and that has to agree with 13. Okay. Now there are many ways to solve this system of equations. Now, let me clear everything so it's easier to calculate. Alright, so I wrote it like this, and we're trying to solve this system. So what do? It's easier if we multiply the top one by 2, so that this is 6c1 plus 10c2 equals to negative 42, whereas the bottom one we multiply by 3 so that it gets exactly the same number. Negative 2 times 3 is negative 6, which will cancel with this 6. And that's 39, and we add them together, and you get c2 equals to negative 3. Plugging that negative 3 back into one of these equations, so let's plug it in here, you get 3c1 minus 15 equals to negative 21. So that 3c1 is equal to negative 6, and therefore c1 has to be negative 2. So that's it. Now, plugging those values back into the equations that we got, we see that the final answer must be x equals to negative 6 e to the negative t, negative 15 e to the negative 5t. All I did was I plugged in these numbers into c1 and c2. And y would be positive 4, c1 is negative 2, we already plugged in. And then negative 3 plugged in here, negative 3 times negative 3 will be positive 9. And that's it.